Welcome back to the channel. Today I want to just quickly go over the difference between a BFS and a level order traversal. And I didn't know this difference when I first started coding. I knew how to do a BFS, and as soon as I got folded by some level order traversal, and I barely I was able to do a level order traversal, figure out during the interview, but there's a slight difference between a BFS and a level order traversal, and it could be used to solve some very specific problems. So let's just go over what a breadth first search is. So breadth first search is usually an operation you want to perform on like a tree. Also, you can use breadth first search to explore a graph, but we're going to be doing it for trees. And why it's called breadth first search is you explore the whole tree breadth by breadth. Or like you like prefer breadth over depth. So you like capture everything in the first level, then you move on to the next one. So you get the breadth to here, and then you do all these ones. So it's called breadth. That's pretty much why it's called breadth first search. Like you prioritize breadth over depth instead of just going far down as a tree in the tree as possible. You just go across. So doing a regular breadth first search will actually just get you the elements here, like this: J, A, M, E, S, right? That since it traveled like J, A, M, E, S, P, it will pretty much get you an array like that, and it'll visit everything in a breadth first manner. But in some cases, you want to grab like the level order. You want to actually return back the array, like an array, and you want to like show for each element what level they are in the tree. So that would more look something like this. So pretend we have J, that's at the first level, right? Then the second level, we have AM, right? The third level, we have ES. And finally, at the bottom, you have that. So that's like the slight difference. On a breadth first search, usually you'll just get back you'll basically just visit all the nodes in a breadth first manner and get an array something like this. But in a level order traversal, you'll actually be able to return back something like this, where you have all the different nodes you visited and specifically what level they were. There's a leak code question called level order traversal, which wants you to exactly just that. Instead of just visiting all the nodes in a breadth first manner, actually return back like each of the nodes, but in their specific level. So you can see, like for level 1, we return a list with 3. For level 2, we return a list of 920. For here, we return a 517. So I'll implement a breadth first search here, and I'll show like that it will return something like this. So how do we implement the breadth first search? So this video is actually also how to implement the breadth first search, or you'll actually get to learn that too. So usually you want to implement a queue with a breadth first search, or use a queue to implement the breadth first search. So from collections, import DQ. So DQ is a double-ended queue in Python. It's pretty much how you implement a queue. And then you initialize a queue here. So how do we explore this in a depth first manner? So usually you use a queue. I'll show the algorithm right now. So you start with an empty queue, right? A queue is pretty much like a line, first in, first out. So you're given like the root of the tree. So you're giving J. So you throw J in there, right? You throw J in there. Now, since it's first in, first out, you visit J. And you look at J, and you put its children into the tree. So J has children A and M. So I'll put A and M into the tree, or into my queue. right? Now, since it's a queue, it's basically a line, we do first in, first out. So this was the first in, so we process it. It has no children, so I literally don't put anything into the queue. And now we process M, right? So now we're processing M. Sorry, yeah. Now we're processing M. M has children E and S, right? Let's just literally throw that into the queue, right? And now we process M. And since it's a first in, first out, next one we process is E, right? So E has a child of P. We just throw that in here. Now we process E. Now we process S next. It has no children. Then we process P next. It has no children. You can see how it like using a queue, like a first in first out data structure, we're able to traverse in a breadth first manner. So that's what I'm gonna pretty much implement here. We're gonna start with a queue. Sorry, let me close that. We're gonna say while the queue, and we'll initialize. See, there's the base case where like if the root is none, just return. Otherwise, I'll throw in the queue my root, and I'll say while there's even elements in the queue, I'm gonna run this operation and I'm gonna store a result. So we'll say element. We'll pop the first element out of the queue. Dot. So that's popping the first person off the line. We're gonna result dot append. Do we want to return the values? Okay. Append dot result element dot value, right? So we pop elements out of the queue, and like I said, after we look at an element, like we look at this element, we're gonna pop its left and right child into the queue. So if the element dot left exists, we're gonna do dot append. Then if it has a right child, you add the right child in. I'm pretty sure just that will return us the right thing there. Or sorry, it's val, not value. You could see we're gonna want to return result. We're doing a breadth first search, so it should get it wrong. You can see like it's returning back everything in a breadth first manner, but it's just not like grouping them up properly by their level. So how would to properly group them up by their level, you have to make this small change, which is this for length of the queue. So now I'm pretty much looping for all the elements in that level. I'm gonna store it in like level result. This is a small change. Then finally you go result dot append level result. And instead of appending to the result, you point to the level result there. That passes 100%, beats everyone. Why did that change, like that slight change, work? So that I just literally showed how you can convert a regular breadth first search into a level order traversal, and it was pretty much like 3 lines of code. So pretty much what you do is you add this little loop right there, and what it's doing is it's looping for all of the elements in that specific level. So, or you're basically grabbing like the size of the queue there. So for example, let's just like reverse a bunch of this. So So remember I started with just J, right? I started with J. And now when I get here, I pretty much say for the length of the queue, it stores the length of the queue, which is only 1. It's going to run this iteration. It's going to run this logic only once, right? So that means it's only going to pop one element out of the queue. So it's going to pop the first element out of the queue. And the first element is going to return A and M. All right. Since this length of queue is only 1, it's going to go back. And then, or since it's only 1, it's only going to run once, and it's going to pop like 9 and 20 here essentially. Then it's going to go back up, and it's going to see there's elements in the queue still. The queue is still greater than 0, and it's going to capture the length of the queue at that specific moment, right? It's like you're going to be like the queue is growing. Why does this work? Well, because it when line 18 runs, it captures the length of the queue at that specific moment. So when you start adding more elements into queue, like when you're processing a certain level, it doesn't affect the length here. So here the length would actually be 2, right? So while I'm capturing like I capture A and then I capture M and E and S, it's pretty much just gonna look through A, M. It's still gonna add like E and S, which is gonna be the next level. But then it won't venture off into like E and S because of that loop. It will stop here, and then at that point we can capture anything we want to know about that level. That's essentially the intuition behind it. And then I'll also like just use pretend we wanted to find the right side. Like we wanted to view a binary tree from the right side. So how would we do that? Like if we wanted to view a binary tree from the right side, which is like if I was viewing it from the right side, it would be J, M, S, P. It wouldn't, A and E wouldn't be in there because it's being blocked by M and S respectively. So you could see like the way to do that is pretty much just do a level order traversal and just use the last element of each level. So yeah, pretty much that's how you solve this other medium question. And then you could do like view from the left side, view from the right side, maybe view from the top, maybe view from the bottom. I don't know if that's possible. Like this from collection support DQ. I'll start with the root. If root is none, while the length of queue is greater than 0. I could probably just put while queue, but I like to be very explicit. And I'll do a level order traversal. I'll have my result here. I'll say what should I say? I'll say last element equals the length of the queue minus 1, right? And I'll say for I in index or for I in range length of the queue. So I'm just looping through the length of the queue like I mentioned. If I equals the last element, what I'm going to do is I'm going to add that element to the result. Last element dot val. Then I'm going to do the same thing. Sorry. I'm going to grab the element here. Element equals Q dot pop left. The element. That'll be like if element dot left, if element dot right. Then I'll just q dot append element, because you don't want to put null values on the queue. It just bloats up the queue and adds more edge cases to look out for. See if that works. See if that beats everyone. 100%. There you go. This video was pretty much how to convert your breadth first search into a level order traversal, and the very slight difference between the two, they're kind of interchangeable, but like if someone tells you do a level order traversal, you're not just going to write the regular BFS algorithm. You're going to have to make this slight variation. I just showed how to do it and how to solve a couple problems using it. See y'all in the next video.